Good evening, everyone. How is everyone? Good? Okay, who all are present? Give your names. I'm good. Thank you. Yes, I'll be completing the whole chapter of sound today. It will be one shot, okay? Good evening. Okay, we'll start now. Okay, everyone is ready. Give a thumbs up if you're ready. Yeah, so let's start with the chapter sound. Okay, am I audible? Okay, okay. So when we say sound, so what do you think of it? So, what do you mean by sound according to your own way? Like, can you give some examples of sound? Okay, give me some examples. Suppose I'm talking to you, my voice is reaching to you, right? So, is that a sound? And what about the sound of a guitar? If you play drums, if you play a flute, or if you hear a dog barking, is that a sound? Right? So now when I say what is sound, okay, so sound is also a form of energy, just like light energy, heat energy. Okay, so sound is also a form of energy which creates sensation of hearing in our ears. Okay, so when the sound, if you are hearing a sound, that means you're able to hear in your ears, yes or no? So that is the, so it is because of the energy that is being formed and which will create a sensation in our ears, okay, of hearing. Sensation of hearing means your ears are your sense organ, right, which by which you can hear. So that's what it says. Okay, now now how will this sensation is produced in your ears? Okay, or how is the sound produced? So it is produced by to and fro motion, or you can say vibration of an object. When an object is vibrating, okay, that time what will happen, sound is created. Okay, so sound is travel or from one object to another through a vibration or to and fro motion. You know what is to and fro motion? Do you know what is a pendulum? Have you seen a pendulum? Yes. So or if you see, so sort of like this, right? So this is your original position. Okay, now if it moves, suppose you're pushing it from this side, so it will somewhere be here, right? Again what happens, it comes back here and again it goes back, and again it goes this to this position, and again it comes back to its rest position. Okay, so that is called to and fro motion. So even the sound is produced through the to and fro motion or vibration of an object. Okay, so the vibration, what will happen, this vibration will create a disturbance in the nearby whatever air particles is there. Okay, if it is air, it will be air. If it is water, liquid, then it will be liquid particles. Okay, so for example, guitar, as I've said, then tuning fork. Okay, this is a tuning fork. You will see in a physics lab also, you will have tuning forks there with different frequencies. Okay, so different tuning forks with different frequencies will create different sounds. Okay, and this one, so if you beat a drum, you can hear the sound, right? Then if you, I think many of you have played this one. So if you stretch a rubber band and with a finger, if you play with it, like, you can hear the sound, right? The more you stretch, the more sound it produces, right? So that is because of the vibrations of the air particles nearby. Okay, so that is how sound is produced. Okay, let's move on. Now, in order to, now we have seen that sound will travel through vibrations, right? Now from where does it travel, how will it travel, in what material or in which medium it will travel? Okay, so it can be either solid, liquid or gas. Okay, so the different mediums where sound can travel is solid, liquid and gas, and out of these three, solid, in the sound travels fastest in solid. Okay, so remember this. And then next is liquid, and the least will be in gas. So in gas, the sound travels the least. Okay, it will be slow in gas or air. Okay, whereas in solids it will be the fastest. Why? Because the air or the solid particles, they are closely packed. That means it has more density, right? So if the medium is dense, that is denser the medium, faster will be the sound. Okay, and also if temperature is high, the sound travels faster. Okay, so remember these three factors. Yeah, one is the medium in which the sound will travel fastest is solid, and if the density of the medium is more, that means the sound will travel faster, and if the temperature is high, then also the sound will travel faster. Okay, one thing you have to keep in mind, that sound cannot travel in vacuum. Okay, if there is no air, no medium, okay, then you cannot hear sound. Okay, suppose in space, if one of you are talking and the other person cannot hear it, right? Why? Because there is no medium, there is no air, no solid, no liquid. So that time sound cannot travel. But only light travels in vacuum. That's the difference, main difference between sound and light. Okay, light can travel in vacuum, whereas sound cannot travel in vacuum. I think this one you have seen. This one you have played, right? We did two cups. If you take two thermocol cups, coffee cups, and then you put a tie a string there, and you, one person will say, then the other can hear, right? Now what is the medium here? Can anyone tell me? Is it solid, liquid or gas? You can type it out, type the answer. Is it solid, liquid or gas? What is the medium in this picture? Can anyone tell me? Now see here. So if you see, there is a string attached to it, right? So the string is what? String is, y- yes, very good. It is solid. Why? Because the string is solid here. It's not here because we have attached both the cups with the string. Here string is the medium. So the string is a solid. Now if you see the second picture, you see if you take a bell, okay, and if you try to ring the bell in the liquid and you put your ears near the water bucket, then you can also hear a faint sound. Okay, so so that means sound can also travel in liquid. Now here, what is the medium? The dog is barking and the girl is listening here. So what is the medium here in the third picture? So there is no string here, no water. What is there? This is air, right? So air, that means gas. Gas, or you can say air as the medium here. Okay. So that's how sound will travel. So in out of these three, the sound will travel fastest in solid. Okay. Is it clear till here? Yes. If it is clear, give a heart. Okay, now let us see how sound travels. Okay, now we know that the object when it vibrates, the air particles or the particles of the medium, they vibrate, and then how that is how the sound travels, right? But how exactly the particles are vibrating and how the sound is traveling from one point to the other one? Okay, so if you see the picture here on the right hand side, can you see this picture? Yes, the moving one. Yes. So you see here. So if you see, this is the disturbance. Okay, from here you are disturbing the medium. Suppose the sound is traveling from here. Okay, let's say the object is here, and and you see the particles. Let us assume these are the particles of the medium. Okay. Now you see here, this particles is moving to and fro. Yes or no? You see all the particles, they are moving in to and fro motion. They are vibrating and they are moving. And see here, this part, it is hitting the other one. So the other one, what is happening, it is hitting the other one, and then the next one, so it is traveling, all the particles is hitting each other. Okay, and then again it is coming back, right? So that is how sound is traveling, and it will keep on vibrating unless the you are able to hear the sound. Okay, that's how sound reaches the ear. You see, that's what it says. So when an object vibrates, the particles and around the medium vibrates. Now if you see in the picture, you can you see this particles is it stands in the same place, right, in the same position. Although it is vibrating, it is coming back to its own position. That means that particles are not traveling, right? All the particles, if you see, they are in the same line, only they are vibrating in to and fro motion, right? So here what is happening, that's how sound will travel. The particles of the medium will not travel, only the energy will be passed from one particle to the other through vibration, and will pass on through the to the ears. Okay, so that is how sound will travel. Okay, so here you keep a note: the disturbance produced by the vibrating body travels through the medium, but the particles do not move forward themselves. Just what I said. If you see from the picture, I hope it is clear. So the particles are in the same place, but it is only the disturbance is moving and producing the vibrations and moving forward. Is it clear? Same goes for the vibration tuning fork. So if you vibrate the fork, what will happen if you hit the fork? So what will happen? It will vibrate like this. Okay, so the air particles will uh, move to and fro, and that's how it will reach your ear. Okay, so the particles will remain in their own places. Only the vibrations will travel by hitting each other. Okay, let's move to the next one. So this is how this is a visual representation. So when you hit a tuning fork, okay, if you take a hammer, these are different tuning forks you see here, okay, with different frequencies. So if you hit the tuning fork, so it will vibrate like this. So that's how it travels. You see the sound, how it is, that's a pattern how the sound is traveling, okay, from the tuning fork to the object, or the to our ears. Okay, that's how, this is how a sound travels. Another one, you see, this is a so with different frequencies, you see the frequencies given here. You see, if it is only 345, you see this type of pattern. If now if you see 5907, so much of frequency, if you see different patterns when the frequency increases, right? So that's a visual representation of how sound and vibration can create patterns. Okay, that's called semantics. Okay, if you take some dust particles, okay, or sand particles, and if you vibrate those sand particles on a table with different frequencies, you'll see different designs. Okay, so that's how you can, this is the visual representation of how the sound and the sound vibrates. Okay, now this is an activity you do at home, so this one most of you have done. Okay, so here what you'll do, you take some glasses, okay, 5 or 6 glasses, and you put different quantities of amount of water in it. Okay, so if you one, you keep it full, one you get take half, one you take quarter. Okay, that's how you different levels of water you keep. And what you'll do, you take a pencil and you hit the glass, each glass. Okay, you'll see the sound differs in each of these glasses. Why? Because the amount, it depends on the amount of water that you're taking. So that water, so based on the vibration it produces, it will create different sounds. Okay, so that's how you can see, hear the vibrations or the sound of the liquid that it will create. Okay, okay, now you know how the sound will travel through vibration of the particles in to and fro motion, right? Now sound travels in the form of waves. in the form of waves. Okay, so now what type of waves? There are two types of waves. Okay, one is longitudinal wave, another is transverse waves. And sound will travel in the form of longitudinal waves. Everyone knows what is waves, right? Okay, have you seen, like, in a pond, if you throw a stone, you see some ripples there, right? The like wave like structures. Okay, same way the sound is also traveling, right? So that's what it is. Okay, so sound are in the form of waves called as longitudinal waves. So here same thing, the particles are not moving forward, only the energy is traveling through the medium, be it water, be it solid, be it air. Okay, now in longitudinal waves we have this part, you see, rarefaction. Two parts are there, one is called rarefaction, another is called compression. Again rarefaction, again compression, so it's alternate. Okay, if one is compression, one is rarefaction, again compression, again rarefaction. So alternatively you will get the longitudinal waves in sound. So when a object vibrates, so you'll get the sound will create rarefaction, compression, or you can say compression, rarefaction. Either way it is correct. Okay, and we'll talk about it more. So see here. Now this is the music system. Okay, so music system means you're creating, so it will create sound, it will vibrate, right? So you see, so these are, so it will create what, so sound, since we're talking about sound, that means it will create longitudinal waves. Okay, so you see here, so that's how the sound will travel. Now in case of TV, okay, so when you're watching a TV, so what is happening, light is coming, right? Visually you are seeing it, so eyes, through eyes, so but light will not travel longitudinally, it will create transverse waves. To see the light, to see what is being shown in the TV, that time the wave that is create, this light will have transverse waves, not longitudinal waves. That's the difference. Okay, sound has longitudinal waves, light, any form of light, visible light, will be transverse waves. So two types of waves are there, longitudinal and transverse waves. Now what's the difference between both the waves? Let us see that. So see here, as I said, longitudinal waves, you have compression, rarefaction, again compression, rarefaction. Okay, in case of transverse wave, you see the difference. It is like this, right? Like a wave kind of thing, right? So it's not like this. Okay, not straight. Okay, transverse waves is in the form of waves like this kind of. Okay, so here we don't have compression and rarefaction. Here we have crest and trough. Okay, this top part, the top part, all the top parts, they are called as crest, CREST. Okay, so they are called as crest. Okay, and down one, if you see, these are called as trough, TROUGH. So that is called trough. So what's the difference between crest and the crest, trough, and compression and rarefaction? So if you see compression and rarefaction given in the diagram, that means we are talking about longitudinal wave. And if you are seeing crest and trough, that means we are talking about transverse waves. Okay, now what is longitudinal wave? Those waves where the particles of the medium, okay, if they move parallel to the direction of propagation of wave. Okay, suppose if the direction of the from here you are shouting, okay, and another person is standing here, so this is the direction. Okay, so from here your the sound is traveling, right? So that is called direction of propagation, and the particles of the medium, they will be parallel to it, then it is called as longitudinal wave. Whereas in case of transverse waves, so this is the direction of propagation, then the particles will be perpendicular to the direction. Okay, they are perpendicular to the direction of propagation of the propagation of the wave. Okay, so that's the difference. So sound waves are longitudinal waves which are parallel to the propagation of the wave, whereas transverse waves are perpendicular to the direction of propagation of waves. The difference is important, so you should know. Okay, so here for example, you see ripples formed on the surface of the water are transverse waves. Okay, as I said, when you throw a stone, it creates ripples, so that is an example of transverse waves. And longitudinal waves are, for example, are sound waves. We have already discussed this. Okay, now you see here, this is another example. Now see the direction, see the disturbance in longitudinal wave, this is the direction of disturbance. Okay, and you see the direction of propagation, so this is parallel. Okay, so the disturbance is also parallel, both are parallel, right? So that is called longitudinal wave. Now if you see here, you see the transverse waves, So it is, disturbance is perpendicular, right? And direction of propagation is here. So 90 degree. Okay, so it's perpendicular. So can you see the difference between both the waves? If yes, give a thumbs up, or you can write yes also. Can you see the difference? Are you getting it? Okay, shall we move? Okay. Shall we move forward? चलो. Okay, so ये है तुम्हारा difference. Okay, that is longitudinal and transverse waves, which we have already discussed. So यहाँ पे, so if the particles vibrate in the same direction, then it is longitudinal, that is parallel. ठीक है? And if it is a right angle, that is transverse. You can take a screenshot if you want to see the difference. Take the difference, because the differences are also important. Okay. So here we have, in longitudinal waves, we have compression and rarefaction, and here we have crest and trough, which we have already discussed. You see here, this is the crest, this is the trough. Okay, it's mentioned here. Okay, and they are possible in all kinds of media, and transverse waves are possible only in solids. Okay, transverse waves cannot be created in liquid and gases. It is only in solids, whereas longitudinal waves can be created in all the three mediums. Okay, now we'll talk about in details about the compression and rarefaction. Okay, now किसको बोलेंगे compression, which one is the rarefaction, कैसे पता चलेगा? Now you see here all these are stuck together, right? And here you see this is you are having gaps in between. Again they are compressed together, again here. So compression means compressed. Okay, so compression में क्या होता है? We have more density. Okay, where pressure is more and density is also more, that is your compression, इसलिए it is compressed. Now where pressure is less, density is less, minimum, then that part is called your rarefaction. So यहाँ पे density कम है and where pressure is less, that's why it is rarefaction. And here you see the pressure and density is more, so that is your compression. Okay, so same way in air particles also, if you see, so these are the rarefaction. Okay, the space part, and these are the compression, this is the compression. Okay, can you see the air particles stuck together, denser part? So that is a compression, and the loose particles are rarefaction. So it is alternative. Okay, don't draw compression, compression, rarefaction. No, one compression, one rarefaction, one compression, one rarefaction. So that's how you'll do alternative. So they occur alternatively. Don't forget this. Okay, when you draw a diagram, it should be alternate. Okay, is it clear till here? Give a heart if it is clear. Okay, see that's how it moves. So compression, rarefaction, you see how the compressions are moving and how the rarefactions are moving. Okay, so this is how you see the compression and the rarefaction. Okay, yes, okay. Next, the most important part, that is characteristics of sound. Okay, what are the different characteristics of sound? How will you determine different factors of sound? Okay, where you'll get numericals, also few numericals based on this characteristics. Okay, so in Venice, when we talk about sound, we'll talk about wavelength, we'll talk about time period, we'll talk about amplitude, we'll talk about frequency, we'll talk about pitch, and we'll talk about speed of sound, that is velocity of sound. Okay, so these are the six factors you need to study under, or six characteristics of sound. Now when you see in the picture, which one is sound, which one is wavelength, which one is amplitude, time, and frequency, these are the main parts. Okay, so if you see here, can you see the wavelength? Wavelength is denoted by this ulta y. Okay, that is called lambda. Okay, lambda. Okay, so lambda is, that is distance between two compressions, or between two rarefaction. Okay, so if you see here, suppose this is there, or distance between two crests and between two trough is also called wavelength, because these factors are also seen in transverse waves also. Okay, so so in order to understand, that's why I'm giving you in the waveform. So you see here, so between these two or between these two, that is also wavelength is determined through this. Okay, time period, so the amount of time taken for a wave to travel, that is your time period. Now the height of this, okay, or height of this, that gives you the amplitude. Okay, the height of the slope will give you amplitude. And frequency क्या होता है, जैसे per second how many cycles or waves are traveling per second. Okay, so or how many oscillations per second will give you frequency. Okay, we'll study one by one now. Don't worry. So this is wavelength. Now see here, can you see the wavelength? See, either ये ऊपर वाला, okay, or consecutive नीचे वाला. Okay, so that is one complete wavelength distance. So that is nothing but distance. Okay, it is the distance of sound wave travels in one complete cycle. Okay, one complete cycle means this is one complete cycle. Okay, so ये पूरा, this is one complete cycle. Okay, that is between two successive compressions or two successive rarefactions. Okay, and lower frequency produce longer wavelength, that is low pitch, while higher frequency produces shorter wavelength or high pitch. Okay, remember this, low frequency हुआ तो longer wavelength होगा, higher frequency मतलब shorter wavelength. Okay, and what is the formula of wavelength? Wavelength equal to velocity by frequency. Please keep a note of the formula. So wavelength equal to velocity by frequency. Wavelength तो हम लोग lambda, this is a symbol. Okay, and velocity is v, you can write like this. Okay, v, or in or you can write c if it is speed of light, you can write c. Okay, divided by frequency. Frequency is like SM is 9 is there, no, like this. Okay, like this is your frequency, symbol of frequency, nu. Okay, now let's see. So remember this formula, lambda equal to v by nu, or velocity by frequency. Okay, and since it is, we are talking about distance, so what will be the unit? So it will be in meters. Okay, wavelength will be in meters. Okay, let's do the next one, time period. As I've said, the time taken by two consecutive rarefaction or compressions to cross a fixed location is the time period of a sound wave. So अगर दो rarefaction और दो compression एक जगह से पास करने के लिए जो time लगेगा, that is called your time period. Okay, and time period is denoted by t, letter t, and SI unit will be seconds because it is time, so SI unit will be second. And here the formula is time period equal to 1 by frequency. Okay, remember this is another important formula. So frequency is denoted by F also. You can also write F. Okay, F, or you can write nu. It's up to you which one you are comfortable with. Okay, so F also means frequency, nu also means frequency, and time period equal to 1 by frequency. Okay, next one. Next comes amplitude. Okay, we have high amplitude, we have low amplitude. Now what is high amplitude, what is low amplitude? Before that you should know what is amplitude. Okay, so amplitude means maximum displacement of particles in a medium caused by a sound wave. So जितना maximum displacement होगा, that is, this is your displacement. Okay, so एक particle जितना displace होगा, that will give you your amplitude. अगर थोड़ा सा displace हुआ, then that means it is low amplitude. अगर ज़्यादा displace हुआ, then it is high amplitude or more amplitude. ठीक है, and अगर ज़्यादा amplitude है, then it will create louder sound. Okay, if displacement is more, that means it is creating high amplitude. So if it is more amplitude means the sound will be louder. Okay, and if the displacement is less, that means less amplitude means you'll get a softer sound. Okay, so you can identify a difference. If it is a louder sound, that means it is having more amplitude, and if it is softer sound, that means it is having less amplitude. Okay, so it is measured in meter. Displacement, so displacement is nothing, so SI unit will be meter, and it is the height of the wave, as I've said. So if you measure this height or this height, it will give you amplitude. Okay, and it determines loudness. So MCQ might come, so what determines loudness? Which factor or which characteristic of sound determines loudness? So that is nothing but amplitude. So amplitude से पता चलेगा whether a sound is loud or soft. Okay, and also remember this one, larger surface area gives loud sound. If the surface area is more, okay, so it will give more sound. अगर छोटा सा, if area is very less, it will create less sound. Okay, a loud sound will travel more distance and has more energy. Okay, so suppose you have a room full of students. so the sound will be what, loud, right? So it will travel more distance. Whereas if there is very few students there in a small room, if few students are there, then it will create less sound, right? So that means it will go lesser distance. Okay, it will have less energy to travel. Okay, is it clear now? Amplitude. Okay, next one. Now coming to the frequency, another important factor. Okay, now what is frequency? It is the number of vibrations per second. So per second कितना vibrations हो रहा है, that will give you a frequency. Now frequency is measured by the unit hertz. Okay, you can write in short form also, capital H small z. Okay, that is hertz. Okay, and frequency formula is frequency equal to 1 by wavelength. So it is inverse of wavelength. Agar if wavelength is 10 meters, that means frequency will be 1 by 10. So how much will it be? 0.1. Okay, 1 hertz. Or frequency can also be given as second inverse. Okay, that's also another unit of frequency. Now another formula is speed or velocity equal to frequency into wavelength. This is another formula that you need to remember. Okay, these two formulas are there to find frequency. If speed is given, wavelength is given, then you'll take this. Okay, or if only wavelength is given, then you can go with the first formula, that is 1 by wavelength. Okay, so here we, now what will happen if frequency is more? So if frequency is more, okay, that means number of vibrations per second is more. Okay, so more are, so if you see here, this is high frequency. In the diagram, top diagram you see, and the lower frequency will have this kind of wave. Okay, so high frequency you see so much of waves per second it is traveling. Here very few waves are traveling, right? So this is low frequency. Low frequency means low pitch. High frequency means high pitch. In those who know music, those who are studying music, you know, high pitch, low pitch, mega notes, you see, no, high pitch, low pitch. So it is nothing but high frequencies. High pitch means high frequency, low pitch means low frequency. Okay, and if the frequency is more, pitch will be more. If frequency is less, pitch will be low. Okay, and those who are having low frequency, they'll have deep sounds. Okay, and जिसका high frequency है उन लोग का sharp sounds होता है. For example, drum. Okay, so flute का now compare the sound of flute and drum. Okay, so flute का sound क्या होता है, pitch कैसा होगा? Okay, so flute will have low pitch, low frequency. Drum will have high frequency. It is very sharp. You can use compare the sound of drums and you compare the sound of flute. Flutes are having, you know, low frequency, right? It's pleasant to hear. So they are having low frequency, whereas drum is having high frequency. Right? This is the order of pitch. Okay. Flute is greater than violin. Violin is greater than guitar. Guitar is greater than car horn. Car horn is greater than drum. Okay, so that's how the order of pitches. So we have low and high pitch. So greater frequency means high pitch, lower frequency means low pitch. Okay, so this is the difference between loudness and pitch. So what is the difference between loudness and pitch? So loudness is the phenomenon of sound, wave of sound, which is dependent on amplitude. Okay, so loudness depends on amplitude, pitch depends on frequency. That's the major difference. Okay, so if you see, loudness depends on amplitude. If you see the diagram, it will be easy for you to compare. जब loudness is increased, pitch decreases. Okay, उल्टा होता है. Loudness अगर decrease हुआ तो pitch increase होगा. Okay, अगर pitch decrease हो रहा है means loudness बढ़ जाएगा. अगर pitch increase हो रहा है then loudness will decrease. It is opposite. Both are opposite because loudness depends on amplitude, pitch depends on frequency. Okay, loudness is directly proportional to the square of amplitude, whereas pitch is directly proportional to the frequency of sound. Okay, unit of loudness is decibel, unit of pitch is hertz. Okay, so how loud it is, 10 decibel, 2 decibel we say, no? So we should not hear, when you're plugging your earphone, we should not hear loud music. Why do we say? Because our human ear has a limit of loudness. Okay, so if it crosses the particular decibel, then you might even have hearing problems. Okay, so that's why you should be careful while using while playing sound when you're plugging in your earphones. Okay, so this is the difference between loudness and pitch. This is also another important difference that you should know. Next is loudness and intensity. This is also another important difference. Okay, so out of these three, anyone might come. So loudness, intensity. अब ये क्या होता है? Loudness, you know, so the measure of response of the ear to the sound. So you can feel it, right? When the music is loud, when the music is slow. So that is nothing but loudness. Okay, so you can measure through your ears whether it is too loud or less. Intensity is the sound power per unit area. एक पर यूनिट एरिया में कितना पावर ऑफ साउंड इज देयर, दैट विल गिव यू इंटेंसिटी ऑफ साउंड. ओके, जैसे नाउ यू सी अ लाउडनेस इज मेजर्ड इन डेसिबल, इंटेंसिटी इज मेजर्ड इन वाट पर मीटर स्क्वायर. ओके, loudness depends on the sensitivity of the human ears. Intensity depends on the is also is independent of the sensitivity of the human ears. So it depends, does not depend on the human ears. Okay, so these three are the main difference between loudness and intensity. ठीक है. Next important is pitch. Okay, we have already done. So pitch is dependent on frequency. So if frequency is more, that means number of oscillations per second is more, then we have high pitch directly. Okay, low frequency means low pitch, high frequency middle, high pitch. And here what you've studied, loudness. Loudness is pitch is opposite. Okay, and here frequency and pitch, so both pitch depends on frequency, so it is directly proportional. High pitch means high frequency, low pitch means low frequency. Okay, so if you see here, so you can so when you know when it is a noisy, we say no, it is very noisy. So when it does it, so you see the waves, this will try to say it is a noisy note, and this is a nice soothing note. Okay, so loud high pitch note, you see here, this is a loud high pitch note, and this is a soft high pitch note. Okay, this is a loud low pitch note. Okay, and this is a soft low pitch note. So we have both high and both low. Okay, so you see the difference, all the difference you can make it out. So what's the difference here, you can see. Okay, this is loud, this is soft. Okay, left side is loud, this is soft. So you see here, this is high pitch one. Okay, and this is, you see the distance here, here the space you see. So, okay, low one, low pitch is like this, high ones are like this. Okay, it is closer. Okay, till here is it clear? Pitch clear hai? Okay, let's start with the next one. This one is the another one, that is quality or timbre. Okay, we call it as timbre also. So this is also another important term that is used to distinguish sounds if pitch and loudness is same. Okay, two persons are there, both are having same amount of pitch, both are having same amount of loudness. तब कैसे पता चलेगा? How will you distinguish both the sounds? Okay, suppose in a room, two persons are there. ठीक है, अंधेरा, it's a dark room, both are having same pitch, both are having same loudness. Okay, but still you will be able to recognize both the, you can differentiate between both the person's sound or the voice. Now how will you do that? How is it possible? That is because of quality or timbre. Okay, so that will distinguish between the two persons who is having both same pitch and loudness. Okay, so it differentiates between sources like a piano and a guitar, for example. Okay, so here यहाँ पे क्या होता है, it is determined by the nature of the vibrating object. So here it depends on the nature of the object. Okay, what object is it? Is it a round shape? It is a rectangle? Is it a guitar? You know the shape of a guitar, right? Is it a flute? Is it a drum? So based on the shape, based on the size, and what material it is made up of, that will tell us the difference. Okay, so each person has different quality, or even in persons also we have different quality or timbre of sound, which helps to distinguish their voices. Two sounds with same frequency equal to same pitch, same amplitude equal to same loudness, but both sounds appear different to our ears. They have different waveform. क्यों है? Because they have different waveform. Same frequency है, मतलब same pitch है, right? Same amplitude means same loudness, but still also we can differentiate both the voices. Why? Because they have different waveform. The waveform is different. That's how we differentiate. Okay, so this question is also important. So how will you distinguish both the sounds? So you can write it by the quality or timbre. So it depends on the nature of the vibrating object. Okay, and also because they have different waveform. These two key points you need to remember for this topic. Okay, you can see here. You see the difference. Tuning fork, you'll see like this. You see the flute. Can you see the variation? And here you see a clarinet. So both have different waveforms, right? You see the shape of the waveform, right? So all are having different types of waveform. So that is nothing but timbre or quality. Okay. Next, coming to the speed of sound or the velocity of sound. So speed of sound depends on the medium and not the source. कहाँ से आ रहा है? We don't have उसका मतलब उससे मतलब नहीं है. लेकिन on which medium it is traveling, so that will distinguish the speed, or that will determine the speed of the sound. Okay, so in solid it will be different, in liquid it will be different, in air it will be different. Okay, so frequency depends, but here if you see, keep a note, frequency depends on the source and not the medium. But if frequency we are talking about, then it depends on the source. Okay, whether it is a guitar, whether it is a music system, whether it is a let's say a drum, so it depends on the source. It does not depend on frequency. Air है, water है, liquid हो या solid हो, it does not depend. उसको मतलब है कहाँ कौन सा source है. But in case of speed, it depends on the medium and not the source. तुम drum भी बजाओ, कुछ भी बजाओ, but the medium has to be, it depends on the medium. अगर solid में different sound आएगा, speed will be different, in liquid it will be different. If you're taking a guitar in solid and in liquid, same guitar you are doing in both the things, so both दोनों में speed of sound will differ because it depends on the medium. Okay, speed of sound increases with temperature. Okay, if your temperature is warm or hot, okay, the sound will hear it fast. And if it is like cold weather and all, so the sound will travel a bit later. Okay, so it will delay. So that's how, so it is depends on the temperature. So increased sound will means the temperature will, if the temperature is more, sound also, speed of sound will also be more. Speed of sound is less than speed of light. Okay, that everyone knows. Always remember, speed of light is always faster than the speed of sound. That's why we see the lightning first, and then we hear the roar of the lightning, right? So why? Because speed of sound is less than speed of light. Light pehle dikhega, then the sound of the thunder will come. Yes or no? So that's why we say speed of sound, because speed of sound is less than speed of light. That also question comes, why do we see lightning first and then the sound of the thunder? Okay, and always remember, as I've seen, speed of sound is fastest in solid, slower in liquids, and slowest in gases. So sound travels fastest in solid. Okay, so if you see the in the graph, if you see the column, solid, liquid, gas, these are the different substance. If you see and see the speed. Okay, so if you see here iron and all, you see, so see iron, so iron speed you see in solid 5950. Okay, now in liquid, water speed is 1531 in water. Okay, in distilled water it is 1498. Okay, so hydrogen you see 1284. Air you see in gas, air 346. You see it's the slowest. Yes or no? You see in solids you see 6420. All this you see, and you see in the gas it is very less. Yes or no? So compared to solid, liquid, gases are the least. So speed of sound is lowest in gases. Okay, then comes liquid, and highest will be in the solids. And speed is measured in meter per second. Okay, just like others you have in motion we have studied, so same thing, only speed or velocity is meter per second. Okay, now can you tell me this question, which characteristic, yes, you need to study. Okay, you need to understand the concepts, how you about different characteristics of sound. Amplitude means what, frequency means what. First understand the concept, then only you'll be able to give the answers. Okay, now for example this question, you tell me which characteristic of sound will help you to identify your friend by his voice while sitting with others in a dark room. So is it loudness? Is it quality or timbre? Is it pitch? None of this. Give me the answer. No, you don't have to memorize the chart. It's just a way to show which one is how the speed of light, speed of sound travels in different mediums. So what will be the answer here? Okay, you're going for B. What about others? Okay, yes. So those who have answered B, it is the correct one. Okay, so it's the quality or timbre. So timbre or quality will determine. So it will help you to distinguish the voice of a person. Okay, from the other. So it will distinguish one person's voice with the other one. Okay. Okay. Let's do this one. Numericals. Okay, a sound wave has a frequency of 2 kilohertz. Okay, frequency is given as 2 kilohertz. Now when kilohertz is given, so that means you have to convert it into hertz. That is 1000. Kilo means 1000. Okay, so 1 kilohertz equal to 1000 hertz. Okay, and wavelength, you see, this is given as 35 centimeter. You have to convert it into meter. All the units you have to take convert it into SI unit. Okay, how long will it take to travel 1.5 kilometers? So here distance is given in kilometers, so you have to convert it into meters, so multiply it by 1000. Okay, okay, we have already got an answer. 2000 hertz. 2000. Okay, 2 kilohertz. Okay, yes, 2 kilohertz means 2000 hertz. And wavelength will be how much? 35 centimeter. You may convert it into meters. Okay, 100 centimeter equal to 1 meter. Yes or no? So 35 centimeter will be how much? So this is how it is. Okay, so it will be 0.35 meter. Wavelength, distance will be 1500 meter. When you're converting 1.5 to meter, kilometer to meter. Okay, now now you have to find out what, how long. That means time period, time you have to take out. Okay, what is given? Frequency is given, wavelength is given, distance is given, right? So which formula you will use and what we'll find out first. So first we'll find out the speed or the velocity. Okay, v. So v equal to what? F into lambda. We have already discussed this one, lambda, right? Lambda equal to velocity by frequency. So we can write velocity equal to frequency into lambda. Yes or no? So put the values, you'll get 700 meter per second, right? Now velocity is also equal to what? Distance by time, right? Speed equal to distance by time, or velocity equal to distance by time. Yes, very good, correct. 2.14 second. So you put, so time equal to what? Distance by velocity. So 1500, distance is already given, 1500 meters. 1500 divided by 700, so that will give you 2.1428 seconds. So here option A is the correct one. Okay, so 2.14 second is the correct answer. Is it clear, everyone? Give a thumbs up if it is clear, or say yes. So you need to remember the formulas. Okay, so remember all the formulas that I have given. Write it in a notebook. Okay, memorize it, and then as per the question you put down the formulas and find it out. Okay, and always remember to check the units. Always verify the units what is being given, whether it is meter, kilometer, everything you convert it into SI units. Okay, okay, good. Now, okay, we are almost end of the chapter. Range of hearing. Okay, so now some of the sounds we can hear, but some of the sounds we cannot hear. Okay, so for example, bats can hear some sounds which we cannot hear, right? Okay, so those so we, because our human ears have a certain range of hearing, that is called as range of hearing. How far or how much frequency we are able to hear. Beyond that, or anything low or anything beyond the maximum point, we will not be able to hear. Okay, so in humans the audible range is between 20 hertz to 20,000 hertz. If the sound frequency is between this limit, 20 hertz to 20,000 hertz, then we are able to hear. Okay, anything below 20 hertz we will not be able to hear. Anything above 20,000 hertz also we cannot hear. The ones below 20 hertz is called as infrasonic sound. okay, which we cannot hear. And the ones above 20,000 hertz is called as ultrasonic sound. Okay, so infrasonic and ultrasonic. You see here, see the difference of waves here. Okay, this is infrasonic, this is ultrasonic. Okay, so human range, remember the human, what is the range of all the three? Okay, infrasonic, ultrasonic and audible range. So audible range is, human audible range is 20 to 20,000 hertz. Between that is the range of human audible range. Okay, now what is the ultrasound? You see, ultrasonic sound is how much? Above 20,000 hertz. So what is the use of this ultrasound? Okay, so let's see. So one is sonography. We have already, you must have already heard of sonography or ultrasound. Patients going for to do, are given to do ultrasounds, right? So that is nothing but use of ultrasonic waves. Okay, so ultrasound, so one is medical imaging. So if you, someone is pregnant, so you can see the picture of the image of the baby, right, or the fetus, so through the ultrasound. Okay, then if a metal is having any cracks which you cannot see clearly with your eyes, we can use ultrasound and find it out. Also, if you have to clean some delicate instruments, mostly industrial metals or instruments, then we can go for ultrasound. It helps in cleaning of the delicate instruments. Okay, so and also in sonar detection, if in below if you want to detect any submarines, and also how does the ship they work, they work on sonar. Okay, sonar detection, so that all they also uses ultrasound. Okay, so if there is any leakage and all this as metal leakage and all, so this flaw detection can also be done with the help of ultrasound. Okay, so these are some of the again same thing. So it is used to clean objects like electronic components. So components to be cleaned are kept in a cleaning solution, and ultrasonic waves are sent into the solution. Due to high frequency, the dirt particles get detached from the components. Everything we cannot clean by hand, right? So so what we'll do, mostly electronic components, we cannot do it directly with our hands. So we'll use ultrasonic waves to clean those dirt. Okay. Then it is also used, as I've said, to detect cracks in the metal blocks. Their ultrasonic waves are sent through the metal blocks, and if there are cracks, the waves are reflected back, and the cracks can be detected. So if the waves are getting reflected, that means there is a crack in that metal. So that way we can identify where the crack is. Okay. Another is used in ultrasound scanners, as I've said, to get images of internal organs of the human body. Then it is used to break small stones formed in the kidney into fine grains so that they are removed through the urine. So if you know, you have heard of kidney stones, अगर उसको तोड़ना है छोटा छोटा small stones, okay, so that if the stones are very less, so you can use ultrasonic sound to break those small stones so that it becomes fine grain like sand particles, so that it comes out in the form of urine, in the urine. So you don't have to go for operation and all. You don't have to operate for the kidney stones. So you can, if it comes, so if the stones are small, then you can go for this method. Okay, so that's some of the applications of ultrasonic sound. Another one, as I've said, sonar. So sonar is stands for, what is the full form of sonar? Sound navigation and ranging. Okay, so it stands for sound navigation and ranging. So it also uses ultrasonic waves to measure the distance, direction and speed of underwater objects. अगर ऊपर में एक ship है, नीचे में कोई another something object is there, any submarine and all are there, through sonar we can detect how deep, at what distance it is present. Okay, so or how much distance, or in what direction it is traveling, in what speed it is moving, so that everything can be calculated using sonar. Okay, so you don't need so much in details. Okay, I'm just giving you the application of ultrasonic sounds. Okay, so these are some of the applications of ultrasonic sound. Okay, so that's all for your course. Thanks everyone for coming, and if is there any doubt, anyone is having any doubts, and if you want me to teach any other chapters, let me know so that I'll um, make a video and I can have a class with you. Okay, is it clear everyone? Give a thumbs up or a heart if it is clear. Anyone having doubts, let me know. Okay, good. Okay, I'm there. So you can drop me a message if you have any doubts. Then I'll help you out. Okay. And if you have not subscribed, you can subscribe my channel, and you can uh, and you'll get a notification there. Okay. Any other videos I'll be coming, so I'll do it. Most welcome. Okay. So have a good night, everyone. Thanks for coming.